Hey everyone, welcome back to the channel. Today we are continuing our array series in Rust and the problem we are solving is LeetCode 347 top k frequent elements. This is one of the most important problems in array because it teaches you how to count frequency efficiently and find the most common elements, a pattern that shows up in many interviews questions. We will start by understanding the problem statement and walking through an example. Then I will show you the brute force approach and how we can optimize it step by step into being efficient Rust solution. So grab a coffee and let's dive right in. So let us try to solve LeetCode problem 347 of k frequent elements. So we are given an integer array nums and integer k. So we have to return top k most frequent elements from the array nums. We may return the answer in any order. So in the example 1, we are given an integer array nums where 1 appear 3 times, 2 appear twice, and 3 appear single times. And we have to return top 2 frequent elements from the array. So we know the most frequent element in the array is 1. So we will add 1 to the output. And the second most frequent element is 2. So we will add 2 to the output. If the value of the k is 3, we will also add 3 to the output. It is also given that the value of the k will not greater than the distinct elements in the array. And the input array will never be an empty array. So let us try to solve this problem using a brute force approach. We will start using a HashMap to store each number and its frequency in the given array. Let's say, for example, we have this array. The value 1 appear 3 times. So we will add 1 as a key and 3 as its frequency. The value 2 appear twice. So we'll add 2 as a key and 2 as a frequency. The value 3 appear single time. So we'll add 3 as a key and 1 as its frequency. Once we build this frequency map, we can simply sort the entries by their frequency in descending order and pick the top k elements, in this case the top 2 elements. Now this approach works fine, but it's not very efficient because sorting an entire map takes big of log and time complexity, and that's unnecessary because we don't actually need to sort all the elements, we just need the top k frequent ones. To make this more efficient, we can use heap, specifically max heap. We will use the same hash map to count the frequency, but instead of sorting, we will push each pairs into the max heap where the key will be the number of occurrences. Then pop the top k elements from the heap to get our answer. This reduces the time complexity because popping an element from the heap is log of n, and since we have to pop the top k elements, the time complexity becomes k log n, which is much faster, especially when the k is much smaller than n. But it turns out that there is actually even better solution with a better time complexity of big O of n, linear time complexity. So next we will try to solve this problem with a linear time complexity. So let us try to solve this problem with linear time complexity using a Bukcet sort. So we will be using the same hash map to count how many times each number appears in the array. And then comes the bucket part. We know the maximum possible frequency of any number is the size of the array because in the worst case all elements could be same. So we will create a bucket of the size of the array where each index represents the frequency and each bucket holds a list of the numbers that appears that many times. So let us try to fill these buckets. So for each pair in our frequency hash map, we will push that number into the bucket that matches its frequency. For example, 1 has a frequency of 3. So we will push 1 to the index of 3. Similarly, 2 has a frequency of 2. So we will push 2 to the index of 2. Similarly, 3 has a frequency of 1. So we will push 3 to the index of 1. If two numbers have the same frequency, we will push the number in the same bucket. Say for example, 2 and 3 appear twice. So we will push both 2 and 3 to the same bucket. Now once the bucket are filled, the last step is to collect the top k elements starting from the end of the list, since the higher frequencies are at the end. We loop from the higher frequency down to the 1 and keep adding the numbers to our result list until we get the top k elements. So we will start from the index 6. In index 6 the list is empty, so we will move to the index 5. In index 5 the list is empty, so we will move to the index 4. In the index 4 the list is empty, so we will move to the index 3. In index 3 we have the value 1, so we will add 1 to our result. Then we move to the index 2. In index 2 we have the value 2, so we will add 2 to our result. Once we get the top k frequency element, we will return the result. So this approach is more efficient because we only traverse the array and the bucket once, so the time complexity is roughly becomes big O of n, which is much faster and efficient than using a sorting or using a heap memory. With this in our mind, next we will move to our coding part. So let us start with our coding part. At first we declare the mutable variable, let's call this a map, and we initialize that with a HashMap. In Rust, to use a HashMap, we need to import that from the standard collection library. So let's import that. We will use this map to count how many times each number appears in the numbers vector. For that, we can use a for loop and iterate through the numbers vector to store the value and its frequency in our map. So we can just say for num in nums vector, and inside the for loop means we can just say map dot entry of num of insert 0 and increment that with the value of 1. The entry function of the HashMap will check if the key is present in the map or not. If the key is present, it returns the value, and if it not, it goes to the OR insert function and insert the key with the default value 0. And at the end, we are just incrementing the value by 1 and store that in the map. Now let us create our bucket. So we will create an mutable variable. Let's call this a bucket. And we initialize that with a vector macro containing an empty vector, and we give it a size of nums dot length plus 1. We also specify the type of the bucket, which is vectors containing vectors of integer. We will use this bucket to hold the list of the numbers where each index represents its frequency. Next, we will use a for loop to iterate through the key value pair of our map and store the value in our bucket. So we can just say for key value in map, we can just store that in our bucket. After we have successfully stored the value in our bucket, we will iterate through the buckets from the end and get the top k frequent elements. So next we will loop through the bucket in reverse order. So in Rust we can do it like for I in 0 to bucket length, and we use the reverse functions to loop it from the reverse. And then inside the loop we have another loop which goes through the every number stored in the current bucket. So if multiple numbers have the same frequency, then the loops will take care. So we can dash for num in bucket of height, that is the current bucket, and then inside the loop we can just push the current number in our result. So let's make a variable called its result, and we declare with a vector. We will store our result in this variable. So we will just say result dot push number, and then we also put a check that if result dot length
is equals to k. That means we got the top k frequent element. We just return the result. Return result. And at the end, we also return the result. So let us now try to run this code. We have successfully executed the code and we pass all the three test cases. So let us now try to submit this code. So as you can see, we have successfully submitted the code and the runtime we got is 0 millisecond, which is super efficient.